In the name of Allah, the most compassionate, the merciful.
With the help of photoluminescence spectroscopy, a contactless probing method in which we can easily find the electronic structure, band gap determination, and impurity level and defect detection. Nitrogen vacancy color center and silicon carbide color center may offer great opportunities for the futuristic quantum application.
Photoluminescence. Photo is defined as using or produced by light. An example of a photo used as a prefix is in the word photograph, which is an image taken with the help of light. Luminescence. When a crystalline solid absorbs energy and re-emits it in the visible region of electromagnetic spectrum, then this phenomenon is called luminescence. Photoluminescence. If the light emission from a matter occurs due to absorption of photons, then it is called photoluminescence. It is a two-step process: excitation of electrons from a lower energy state to a higher state as a result of absorption of energy. Emission of light radiation when the electrons fall back to a lower energy state. Fluorescence. The time during which luminescence can be observed depends on time interval between the acts of excitation and emission. In fluorescence, the light emission is immediate after the excitation process. And in the following diagram, fluorescent solution under UV light absorbed photons are rapidly re-emitted under longer electromagnetic wavelengths. And in the following diagram, we can easily see there is a difference between fluorescence and phosphorescence. Phosphorescence, if the luminescent emission continues for sometimes perhaps hour even after the excitation has been ceased, it is known as fluorescence or afterglow. And in the following diagram, we can easily see fluorescent bird. A fluorescent material can store the absorbed light energy for some time and release light later, resulting in an afterglow that persists after the light has been switched off. Depending on the material, this afterglow can last anywhere from a few seconds to hours. If the crystalline ZNS zinc sulfate when illuminated by X-rays, then it displays fluorescence. Color center. Color center is a crystal defect that absorbs light in a spectral region, and as a result the color of the crystal is changed. It has been observed that most insulator crystal and pure alkali halides are transparent to visible light. When such crystals are exposed to radiation, they appear to be colored due to the selective absorption of some component of visible spectrum by certain imperfections, which are usually present in the crystal. A color center is thus a lattice imperfection or defect which absorbs visible light. The transmitted beam received by our eyes contain only the remaining complementary colors. Type of color centers. Color centers can be put into two different categories: electronic centers and Hole centers. Electronic centers include F centers, FA center, R centers, and M centers. Hole centers are anti-morphs of electronic centers and are known as V centers. For example, V1 center is an anti-morph of the F center. V2 center is anti-morph of the R1 center. V3 center is anti-morph of R2 center. V4 center is an anti-morph of M center. F center. The name of F center comes from German word for color Farbe. The F center is alkali halides is negative ion vacancy which is occupied by one or more unpaired electrons. Electrons in such a vacancy tend to absorb light in the visible spectrum such that a material that is usually transparent becomes colored. This is used to be identify many compounds. F centers occurs in ionic crystal, especially the alkali halides such as NaCl, KCl, etc. F centers are often paramagnetic and can be studied by electrons. Paramagnetic resonance techniques: the greater the number of F centers, the more intense the color of compound. One way of producing F center in a crystal artificially is to heat in an atmosphere of the metal of which it is constituted. And in the following there are three different diagrams in which we can easily see the ionic crystal F center. An F center in a crystal which is represented by negative E, And in the third one diagram, we can easily see an F center in a crystal, which can be represented by electron E minus. The electron trap at the anion vacancy is called F center. This electron can absorb light of the certain wavelength and can emit light of other wavelength, which leads to change in the color of the crystal. NaCl becomes yellow under this condition. F center produces excess metal defects in ionic crystal. It is also known non-stereometric defects. Colored crystals are less dense than uncolored crystals. And in the following diagram, F center E trap in ionically vacancy. Conduction band absorption, electron potential energy, metal excess defect, and metal excess defect. Other electronic center, when a crystal already contain F center is irradiated at elevated temperature by light that is absorbed by these F center. A new absorption band on the long wavelength side of the F band appears. The resulting center are called F center. Some of the electrons which are being excited by the incident light become free by absorbing heat. A reversal process which will give rise to an F center when a crystal already containing F center is similarly irradiated by light that is absorbed by these centers. M center consists two adjacent F centers and R center consists of three adjacent F centers. Hole center, we can also say V centers, like electrons hole can also get trapped at vacant lattice site to produce color centers. The resulting color centers are called V centers and are anti-morphs to the F centers. A VK center is formed when a hole is trapped by a pair of negative ions. Generation of color centers. Color centers may be produced by one of the following methods: by additive coloration, coloration by ionization radiation, electrolytic coloration. Additive coloration method. This can be divided into the following two processes: introduction to the chemical impurities and introduction to the excess of metal ions. The imperfections which are responsible for the color centers may be in interstitial impurity atom added to material. For example, when excess Zn are present in ZnO, it becomes yellow. Introduction to excess of metal ions. When a colorless alkali halide crystal is heated in an atmosphere containing excess alkali metal vapor, it becomes colored. Coloration by ionization radiation. It is possible to produce color centers when a crystal is irradiated with high energy radiation such as X-rays, gamma rays, neutrons, and electron beam. And the formation of color centers by irradiation depends upon the following factors: type of radiation, dose rate, temperature, purity, mechanical stress of the sample. Electrolytic coloration. In this matter, color center can be produced as a result of electrolytic conduction when an electric field of about 100 VCM is applied to a crystal held at 100 C. A cloud of color center emerge from the pointing cathode and migrate towards anode. And the trap hole centers can be produced in some alkali halide crystal by using pointed nanode. Color center produced in this case are due to excess of one of the elements as